Alright, this is lesson 1.4 for our Precalc 11 class. Unit 1 is called Radicals and Rational Exponents. Lesson 4 is called Operations on Radicals 1. In this lesson, we're going to talk about words to describe radical numbers. We're going to talk about how to multiply and divide radical numbers. And we're going to talk about what it means to rationalize the denominator. First up, let's talk about words, some key terms, and Digo's going to help us do that. First of all, we have radical. That's the word we use. Index is a word we'll use sometimes. And radicand is a word we will definitely use. All right, if I ask you to identify the radicand in this example, B would be the radicand. The index, A would be the index. The radicand, 81x squared would be the radicand. The index, that would be 3. Here you go, a couple helpful notes. The radicand is the thing underneath the radical. The radical symbol is that bar, and the index would be the number or the nth root we're working with. When there is no index given, the index is 2, as in square root. Or if there's a 3 there, we're doing third root, the index would be 3. Radical is a tricky term because radical refers to that bar symbol. Radical is also an umbrella term we talk about when we talk about any index of radicals. Square roots, cube roots, fourth roots, fifth roots, they're all examples of radicals. All right, a couple more words. We have mixed radicals. We also have entire radicals. Mixed radicals or entire radicals. Which one is this? This is an entire radical. As in the entire thing is underneath the radical symbol, except for the index of 5. This one is a mixed radical, because we have an 8 outside of the radical as a base number. 8 times square root of 7. Or as I like to say, 8 root 7. This one is an entire radical. 25 is all in the radicand. 80 is the entire radical. It's all on the radicand. Mixed number, we have a fraction times our square root. Mixed number, we have a negative number times a third root. Now you know the key terms, and now you made Indigo happy. Those are tears of joy, Taylor. Tears of joy. Alright, so some examples with working with products. One helpful rule when you work with multiplying square roots is that you can take 2 square roots and you can multiply them together and make each radicand a product under one radical. In other words, the square root of A times the square root of B is equal to the square root of A times B. We won't always use that to simplify every example, but sometimes it's helpful. Example A, we have the square root of 8 times the square root of 40. Well, that's, using the rule, is the square root of 8 times 40. Instead of multiplying 8 and 40 together and then trying to simplify the radical, I'm just going to leave 8 and 40 factored out. I know 40 is 8 times 5, so I can see that I have a pair of 8s. So when I simplify this, it's going to be 8 root 5. That's fully simplified product. Same procedure for example B. I've got root 15 times root 10 is equal to the square root of 15 times 10. But I see 15 is a 3 and a 5 multiplied together, and a 10 is a 2 and a 5. They both have a common factor of 5. So I'm going to pull that pair of 5 out, leaving 3 times 2 inside the radicand. So we get the mixed number of 5 times the square root of 3 times 2, or 5 times root 6. The next one, we have a whole number 4 times a mixed radical. 4 times 3 root 7. I'm just going to multiply the whole numbers that are outside of the radicals together, just like I would 2 numbers inside of the radical. So 4 times 3 is 12, so 12 root 7 is our final answer. Example D, we have a mixed radical times a mixed radical. I'm going to multiply the numbers outside of the radical together, 9 times 5. And I'm going to multiply the radicals together, root 3 times root 21. 9 times 5 is 45. And then root 3 times root 21. I know root 21 is root 3 times 7. So when I multiply those together, I got a pair of 3's. A pair of 3's comes out. We're left with 45 times 3 root 7, which simplifies to 135 root 7. That's multiplying. Product means multiplying. Now with quotients. Quotients mean dividing. Our rule of thumb here, which we will sometimes use to simplify, is that the square root of a number divided by the square root of another number is equal to the square root of the first number over the second number. As in, you can put them under one radical. Alright, we'll use that sometimes, but not always. Example A, when you're simplifying a fraction with a radical in it, there's two things we're trying to do, and you could do either one first. It'll change the way your work looks, but it won't change your answer. Right now we're going to stick with the first thing, and we just want to simplify square roots. And then after that we can simplify fractions. We can simplify fractions and then square roots, but we're working with radicals, so simplifying square roots is probably going to be the best way to start with these. Alright, so the square root of 12, if we cut some steps short, is 2 root 3. So if 2 over 6 is the fraction that can be simplified as 1/3, so 2 root 3 over 6 would be 1 root 3 over 3. And then 1 root 3 is just root 3, so root 3 over 3 is our final answer. Now the next one, same thing. I'm going to start with simplifying the square root. The square root of 300, 100 times 3, is going to be 10 root 3. So I have 10 root 3 over 5. I know that 10 divided by 5 is just 2, so I can simplify this to be 2 root 3. Or my intermediate step, 2 root 3 over 1. If I cancel a 5 off top and bottom, but yeah, final answer is 2 root 3. Example C and D. So example C, I can simplify the radicals and then simplify the fractions. However, in this case, the numerator and the denominator are both radicals. So I could put them under one radical sign. And it just so happens that 162 divided by 9 is 18. So I'm going to do this path first. I'm going to divide it out and get square root of 18, and now I'm going to simplify the radical. Thank you for the nice clean whole numbers. You're welcome. Square root of 18 simplifies to 3 root 2. Alright, if you simplify the square roots on that one, and you simplified the square root of 162, and you simplified the square root of 9, and then you canceled and simplified the fraction, you would end up with the same answer. It would just take a few more steps. This rule that we're using on this slide just kind of helps make this go faster. Example D, we're going to do the same thing. I'm going to bring the numerator and the denominator under one full radical. 1,225 divided by 5 is 245. So this simplifies to the square root of 245. And let's see here, Ethne's calculator told me that 245 is 5 times 49. So I can pull a 49 out of there as a perfect square and simplify this to be 7 root 5. Alright, that's how you divide with radicals. A couple of things to note. These rules can and do fail, and here's when. If A or B are a negative number, this rule will not work. For multiplying, it does not work. For dividing, A cannot be negative, B cannot be negative, but B can also not be 0. You can't have a negative exponent, first of all, because, sorry, not exponent, you can't have a negative radicand because the definition of a square root is something times itself equals the radicand, and the square root of that radicand is that original something. To make that less general, 2 times 2 is 4, so the square root of 4 is 2. Negatives don't work because there's no number times itself that equals a negative. If I pick a negative number, a negative times a negative is a positive. If I pick a positive number, a positive times a positive is a positive. There's really no way to square a number and get a negative. It doesn't make sense. So right now, we don't really have any way to deal with a negative radicand. So we just say A and B cannot be a negative number. We can't do negative radicands for now. Also, with dividing, B can't be a 0. Only with dividing, the denominator can't be 0. The reason being is you can't divide by 0. as Taylor learned today, and Addison, that if you have 10 cookies and you divide those 10 cookies among 0 friends, you're, well, you have no, well, it doesn't make any sense, because you can't divide into groups of 0, and you also have no friends, because you have 0 friends. And I butchered that joke. I'm really sorry. I'm not going to re-record this video just for that joke. Sorry. And you do guys, Addison, Taylor, you do have friends. That was just an example. Please don't cry. Anyways, so when you're dividing, you can't divide by 0. So in this case, b has to be strictly greater than 0. All right, third and final thing. In math, we don't like leaving simplified answers with a square root in the denominator. If you have a fraction, don't leave that radical symbol on the bottom. That's just the way we do things in math. There are reasons for it, and those reasons are kind of nerdy, but just know that that's the case. So when I say rationalize the denominator, that means if you have an answer with a denominator in it, we want to rewrite that answer with an equivalent expression that has no radical on bottom. Some examples here. C is rationalized, and E, the way it is written, is rationalized. Those answers aren't fully simplified, but they have rational denominators, so we call these rationalized. A has a square root of 8 on bottom, so that's not a rationalized denominator. B as well, D and F as well. Now a lot of these we can simplify or rewrite with rational denominators really easily. However, when we get stuff like this, there's a trick we can use that'll work every time. It's not the quickest way always, but it will always work. If I ask you to rationalize the denominator, or if a quiz does, or homework assignment, or whatever, what you can do is multiply the numerator and the denominator by the radical in the denominator. So in this case, our denominator is square root of 20. I'm going to multiply 3 by root 20. I'm going to multiply root 20 by root 20. I'm going to get 3 root 20 over 20. And now I'm going to simplify my radical and simplify the fraction and get my final answer. This is good practice for dividing with radicals, which we did earlier. And we could work that out. You can check that out here. Feel free to pause the video if I go too fast. Or double speed if I'm too slow. Alright, example B, we're going to do the same thing. The denominator is root 54. So I'm going to multiply the numerator and the denominator by root 54. Root 54 times root 54 is just 54. On the bottom we have 54, and on top we have 7 root 54. Now I'm going to go about simplifying the root 54. I'm going to simplify my fraction, cross off a 3 on top and bottom. I'm left with 7 root 6 over 18 as my rationalized and fully simplified answer. Example C, we're also multiplying the top and bottom by root 54 and simplifying the root. Example D, the last, and for some reason the easiest example, or most simple, we're multiplying the top and the bottom by root 6. No simplification necessary. Alright, so we now have some words we can use to describe radical numbers. We have radicand, we have radical, we have index. We have mixed radicals, we have entire radicals. We also know how to multiply and divide radical numbers. And speaking of dividing radicals, we also know how to rationalize the denominators.